Okay, this is homework 1, question number 18. A sound source is located somewhere along the x-axis, and experiments show that the same wavefront simultaneously reaches listeners at x is equal to -7 and x is equal to +3. Part A asks, what is the x-coordinate of the source? And we know that because the same wavefront reaches the listeners at the same time, we can set phi, the phase difference, to 0. So these are the equations that we know. So we can set this to 0. And then use that to solve for delta x. So we can do 0 is equal to 2 pi, and delta x is just r2 minus r1 over lambda. And then we can get rid of this, and we get since we solve for R2 and R1, we find that the distance between the 2 points and the source has to be the same, which makes sense because they hear the same wavefront at the same time. And so that means we have to find the midpoint between x2 or R2 and R1. So the midpoint between -7 meters and 3 meters is -2, so that means the source is at x is equal to -2 meters. Okay, so for part B, wait, did I write on that already? Oh, I did. So this is just, okay, a third listener is positioned along the positive y-axis, and we want to find the y-coordinate if the same wavefront reaches her at the same instant it does as the first listeners. So since the third person is also listening to the same wavefront, that means they are the same distance from the source, which is 5 meters, and we know that from part A. So you can pretty much use the Pythagorean theorem to find the y-coordinate, and if you don't remember that, that's a squared plus b squared is equal to c squared. And that is, plug everything in. Y squared is equal to 5 squared. And then solve for y is equal to 5 squared minus 2 squared. And then y is equal to square root of 5 squared minus 2 squared. And that is 4.6 meters.